Today's topic is Menger Sponge. So based on this Wikipedia page, Menger Sponge, this is the picture this showing is the Menger Sponge. It's a very peculiar type of fractal in a three-dimensional. So it is the extension of a one-dimensional Cantor set and the two-dimensional Spirsky carpet. Okay. Its construction is very simple. It have only four steps. We have a normal cube. In the first iteration, we divide the first cube into small cubes like the 27 cubes, such that each face have 9 cubes. And after dividing the initial cube, we take out the middle cube of each faces and inside cube. This is the first iteration. In the next iteration, we again split each small cubes in the second iteration again into 27 cubes and take out the middle one. So we get this is the output of the second iteration. And in the fourth iteration, we do again. We take this simple cube and again split into 27. Okay, this is the process. In the construction of a merger sponge, there are three steps. We have a cube, and then we split the cubes into smaller cubes such that each face have 9 cubes, and after that we remove the middle cube of each face and inside of the cube. Okay, so in the case of a removal of a cube, we have to find out which is the middle cube in a particular in a 3 by 3 grid. For that purpose we use Manhattan distance. So Manhattan distance is, suppose we have a code. This is a coordinate of x, y, z. Okay. So let's say this is the center, 0, 0, 0, the origin, and suppose uh, this is a this is a position of a cube. Okay. So the distance between this point and this point, this is the Manhattan distance. It is not the Euler distance. So based on this Manhattan distance, we find out whether this cube is the middle one or is the outside of the middle one. Okay, so the equation or the condition is very simple. The absolute value of the x plus absolute value of y plus absolute value of z is greater than or 1. So this is the condition. Okay, so the value of this x, y, z. So this based on these values x, y, z, we check whether these values satisfies this condition or not. Okay, if this values is satisfied, then then that cube will be remain. Okay, if any cube will not satisfy this condition, then that cube will be removed. Coming to the unity code, so this is the major part of the creation of the merger sponge. We use three loops for z, x, y, z in order to find the position of the each cubes. Then we check for this Manhattan distance formula. We check for this condition. If it is satisfied, if this condition is satisfied, which means that 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 cube will be remain and other cube, that's all the other cubes which is not satisfied will be removed. So we are not giving any condition for this else part. So we only considering this part because these are the cubes will be remain. And once we find out this position, once we find out this particular cube, we again call this same function. It's a type of a recursive thing. So we calls the again the function with a new position. Okay. So this will create more cubes in the original in the subcube. Okay, so this is the core idea of the merger sponge creation. And for for in order to improve the performance of this thing, we will use a merging of the meshes, because otherwise it's very difficult to handle the performance in the Unity, especially in the case of the iteration 4 and above. Okay, so in order to have a little bit more performance, we try to combine the meshes into one single mesh so that it will become very easier to uh, execute. Okay, so this is the Unity editor. So we have some buttons are given. So once we uh, play, we press the start button. So this is the first cube. Yeah, this is the first cube. We do not start any process. So when we press the next button, the iteration becomes one. So this is the first iteration. In the first iteration, we take out the middle cubes of each face and the one inside the cube. One inside the cube. Okay. Okay. In the next iteration, will be each cube will be split again into the 27 cubes. Okay. So you can see that the each cube will be divided again into 27 cube and take out the middle one. So this is the second iteration. In the third iteration, it's again split into the these cubes will be again split into 27 cubes. Okay. In the fourth iteration, it has some performance issue. Not performance issue, it takes more time to calculate. And now we have um, the fourth iteration. This is the one which we seen in the Wikipedia page. Okay, so that's the construction of the merger sponge.